Velocity time graphs. By the end of this topic, you will be able to describe distance time graphs, describe uniform circular motion. Velocity time graph represent the change in velocity with passage of time. In such graphs, velocity is plotted on y-axis and time on x-axis. The slope in this graph represents acceleration as acceleration is equal to change in velocity by time. The acceleration will be positive if the slope of the graph is positive and vice versa. The area enclosed under the velocity time curve gives the displacement of the body. When a graph is plotted between displacement and time, the slope of the graph represents uniform velocity if the graph is a straight line but not parallel to x and y axis. Variable velocity if the graph is curved line. Velocity time graph for an object moving with constant velocity. Velocity time graph for a body moving with a uniform velocity is a straight line parallel to time axis. Therefore, the slope of the body is 0 and hence acceleration is 0. Velocity time graph for an object moving with a uniform acceleration. When an object moves with uniform acceleration, then it means that velocity changes by equal amounts in equal intervals of time. When object starts from rest, the graph is a straight line, not parallel to any axis. The acceleration of the body can be calculated by finding the slope of the graph line. Acceleration is equal to slope of the graph line. AB by AC is equal to V2 minus V1 by T2 minus T1. The magnitude of the displacement is calculated by finding the area of triangle ABC is equal to half of the base into height is equal to half AB into BC is equal to half into 16 meter per second into 5 second, that is equal to 40 meter. Velocity time graph for uniform motion when initially the body is not at rest. Let us observe a graph where initial velocity of the body is 2 meter per second and then it increases at a constant rate. The graph for such type of motion is a straight line which is not initiating from rest as shown in the figure. The distance covered in a specified direction can be calculated by calculating the area of trapezium BDEA. Distance covered or displacement is equal to half into AE plus BD into ED is equal to half into 2 plus 14 meter per second into 6 second is equal to 48 meter. Velocity time graph when the velocity of the body decreases uniformly to 0. Let us suppose a train is running with a speed of 10 meter per second initially. As driver applies brake, the train starts decreasing its speed uniformly. The velocity time for this type of motion is shown in the figure. The acceleration of the train can be calculated by calculating the slope of the graph line AB. acceleration is equal to slope of velocity minus time graph line AB is equal to AB by CB is equal to 0 minus 10 meter per second by 5 second is equal to minus 10 by 5 meter per second square is equal to minus 2 meter per second square. Negative sign of the acceleration shows that the train undergoes a uniform retardation. Distance covered in a specified direction is equal to area of triangle ACB is equal to half into AC into CB is equal to half into 10 meter per second into 5 second is equal to 25 meters. Velocity time graph when velocity changes non-uniformly. The velocity time graph of a body when velocity is increasing non-uniformly is a curve moving upwards. Slope of the curve is positive and increases with time. The velocity of time both are variable in this graph. When the velocity of a body decreases non-uniformly, the velocity time graph is a curve moving downwards. The slope of the curve is negative and decreases with time. Velocity time graph of non-uniform velocity of an object. When the velocity of an object changes alternatively, the velocity time graph is a zigzag curve. This graph shows that the velocity of an object is increasing at constant rate up to 2 seconds, then decreasing at a constant rate up to 4 seconds, again increasing at the constant rate up to 8 seconds, and then decreasing up to 12 seconds. Graphical derivation of first equation of motion. The velocity time graph of a uniformly accelerated motion of the body having initial velocity u and final velocity v is a straight line. Acceleration is equal to change in velocity per time taken. A is equal to v minus u by t. V is equal to u plus at. This equation is also referred to as velocity-time relation. Graphical derivation of second equation of motion. Let an object start from rest at time t1. Its velocity is u at time t1 and becomes v at time t2. Distance moved by the object between time interval t1 and t2. S is equal to area ABCD. Area of rectangle ABCE plus area of triangle AED is equal to AB into BC plus half AE into DE is equal to u into t2 minus t1 plus half t2 minus t1 into a into t2 minus t1. S is equal to ut plus half at square, where t2 minus t1 is equal to t. This equation is called position-time relation. If the velocity of an object is constant, then a is equal to 0. Hence, the equation becomes S is equal to ut. Graphical derivation of third equation of motion. We can find the distance travelled by a body during the period its velocity changes from u to v. Distance travelled S is equal to area of trapezium OABD. S is equal to half into BD plus OA into OD is equal to half into BD plus DC into OD, because OA is equal to DC. Acceleration A is equal to slope of velocity minus time graph AB. A is equal to CB by AC is equal to DB minus DC by OD, or OD is equal to DB minus DC by A, putting values of OD from above equations. S is equal to half into BD plus DC into DB minus DC by A is equal to half A into V square minus U square, or V square is equal to U square plus 2AS. This equation is known as position-velocity relation. Summary. Let us summarize what we have learnt in this topic. Velocity time graph represents the change in velocity with passage of time. The slope in velocity time graph represents acceleration. Velocity time graph for a body moving with a uniform velocity is a straight line parallel to time axis. Velocity time graph for an object moving with a uniform acceleration is a straight line not parallel to any axis. The velocity time graph of a body when velocity is increasing non-uniformly is a curve moving upwards, and vice versa when the velocity is decreasing. First equation of motion is V is equal to U plus AT and is referred to as velocity time relation. Second equation of motion is S is equal to UT plus half AT square and is referred to as position time relation. Third equation of motion is V square is equal to U square plus 2AS and is referred to as position velocity relation.